go. So I will continue in this video with the first steps to compile Bitcoin Core and run the unit and functional tests. In the last video, in the first one about this specific topic, I recollected all the list of libraries I need to install in my Linux environment in order to be able to then compile the repository which I cloned locally. Therefore, here I have all I need to compile. So we're at step 4 of this article written by John Attack. We just need to compile from a tagged release branch. Let me just see what do they mean. In Git, what is a tagged branch? Okay. A branch where one or more tags have been replied. A branch created specifically for organizing tagged commits. A branch referenced for creating every final tag. Okay, so I can't do specific questions anymore. Okay. So git tag and sort v. Let's see if we can receive first of all what is this command doing. Git tag -n, this lists all the tags in your Git repository along with the first line of their associated annotation. The end flag tells Git to show the tag name along with the annotation message. Sort v, this pipes the output of the first command into sort command. The v flag for sort stands for version sort. It sorts the tag in version order rather than lexicographical order. This means it sorts tags in a way that makes sense for version numbers. Okay. So we can use -v for sort because we know that there's the first command output, right? Version number in a way that accounts for numbers, not just strings. This means it treats the version number properly, understanding that v10 should come after v9, are sorting them lexicographically. Okay. Nice. So continuing to learn every day. Let's go then. Let's put this command here. Okay. So, wow, look here. Dummy tag for commits on master. Okay. Get localhost IP on Linux. Shut down a little clearly. Wow. I will go through all of this. Eventually, I'm really interested. But after a while, it becomes just version release candidate, Then we have Bitcoin release candidate, final, okay, tag release candidate, and then final. Okay, Therefore, we can build one of these. Nice, right? Git checkout to use a tagged release, for example. Git checkout this version here. Well, I do checkout on the last version. v20.1. Right? Yeah. Note switching to v28.1. You are in detached head state. You can look around, make experimental changes and commit them. And you can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch to retain commits you create, you may do so now or later by using -c with the switch command. Okay. Compile Bitcoin from source. Therefore, now we'll launch the compiling commands. So first of all, autogen.sh. Let's see one thing here. Autogen.sh is present as a script here, therefore we can just execute it. Okay, let's see. So auxiliary files, blah blah blah, macros in AC config macro, file build, blah blah blah, LT sugar, LT version, LT obsolete, build aux, yeah, build test driver. So we had a lot of copying operations here. Now configure or for legacy wallet support, blah blah blah. Yeah, we'll just execute configure, which again, let's check. Okay, so we have this script here, configure, which wasn't available before. So it has been made available by autogen. So configure will image configure the work for make the binaries. So we have some binaries here. Okay. For G++, GCC, for egrep, for blah blah blah. Whether to build shard libraries. Okay, so I see a lot of things going on here. C cache, whether C++ compiler accept, blah blah blah. Okay, so there's a lot of configuration. Yeah, okay. Nice. Therefore, we already have, well, build options, option used to compile and link. Okay. Make. So, or if you have multiple CPU cores, which is the usual case nowadays, you can tell make to use all of them and reduce compile time significantly with this. Okay. No make is not a command from GCC, but it is often used in conjunction with GCC. Make is a build automation tool that is used to manage and automate the process of building and compiling code. It reads a file called makefile, which contains a set of rules and instructions how to build and link programs, handle dependencies, and specify which files need to be compiled. GCC is a compiler. It's a tool that translates source code into executable code. GCC is often called from within a makefile, but it isn't the same thing as make. In many projects, especially in C++ development, make is used to streamline and automate the compilation process using GCC. The makefile specifies how to invoke GCC for compiling sources. Okay. So example makefile using GCC. Therefore, I will need to go to the makefile. Okay. So I need to rerun configure, but with this. Okay. Another question. The compilation when running make with GCC, what do I obtain, and what happens if immediately after I ran the same compilation action with Clang? When you run make with GCC, the goal is to build a program. Typically, this means compiling source code files into object files and then linking them together to create an executable program. What do you obtain by running make with GCC? So object files, if your make file is set up to compile source files into object files, you'll obtain .o files. These are intermediate files to contain compiled code, but are not yet executable. Okay. What happens if you immediately run the same compilation action with Clang? Will the Clang compile? I mean, this is a specific, it depends. Okay, so I mean, don't close this. Yeah, whatever. So now put this. Okay, therefore now we can just execute make, and it should compile with Clang. Let's see what happens. It should take some time. Compiling with Clang for Linux users, blah blah blah. Pro tips: if you're recompiling frequently as you're not changing the build configuration, you can skip directly to the make, -G and step. Okay. On the other hand, when you change the build configuration or you are building a branch containing substantial changes to the autoconf automate scripts, make clean. Here's a complete example. Okay. Be sure to use Ccache, the fuzzy compiler cache, to speed up your build. It should already be installed as part of the dependency described. Run. Okay, you can also gain time by building only what you need. See the Bitcoin Core productivity notes. Ccache. Being Ccache installed on my machine, it should be enough to be sure that it is being used to cache compiler work. First, confirm that it is installed, Ccache version. Well, here it's still running, so I'm not able in this moment, unless I open another SSH, but it's not worth. Ensure build system uses Ccache as the compiler. Okay. Yeah, I set it here then, Clang++. You can also gain time by building only what you need. See the Bitcoin Core productivity notes for more. You can run to see all the various configuration options. It's also list, so it may be more practical. Sorry, I was reading here. More practical to search for what you want with grep, configure, grep, A1, your search term. The options I use the most often are with incompatible BDB, as mentioned above, and enable debug for debug builds for reviewing and testing pull requests. Nice, okay. Explain me this tip from an expert which wants me to spare time. In Bash, the default shell in many Linux allows shortcuts for commands that allow you to create custom command that expands to a longer, more complex command when executed. Example of how aliases can help. For example, if you often use make with specific compiler flags and tools, you might have to type something like this. That's fine, but it can get a bit tedious to type, okay? Alias my build. And the command. Now, every time you want to run that command, instead of typing the entire thing, you just type my build. Great. Okay, so nice. Fuzz testing. What the hell is fuzz testing? It's a type of software testing where random or semi-random data is provided as an input to a program with the goal of finding vulnerabilities, bugs, or unexpected behavior. The idea behind fuzz testing is that by feeding a program invalid, unexpected, or random input, you can discover edge cases or potential weaknesses in the program that wouldn't normally be encountered during regular use. This technique is particularly useful for discovering security vulnerabilities, crashes, or unhandled errors that might be hard to reproduce with normal input. How does fuzz testing work? Generate random input. A fuzzer generates random data, which could be anything from random string or characters to malformed files or packets. Feed input to the program, into the target application or system monitor for crashes or failure. The fuzzer monitors the application for abnormal behavior, crashes, memory corruption, or security vulnerabilities. The fuzzer continually runs the application with new inputs and records the results, attempting to maximize coverage and identify potential weaknesses. Okay. What does mean to compile for fuzzing test? Okay. And building, so Okay, so compiling for debug and compiling for fuzzing are related but distinct concepts. While both involve compiling your code in a way that allows you to catch bugs and unexpected behavior, they serve different purposes and focus on different aspects of the development and testing process. Compiling for debug. Compiling for debug is aimed at making the program easier to debug when you're trying to diagnose specific issues or understand program behavior during development. Key features: debug symbols. This adds debugging information to your compiled program. No optimization. Verbose output. Instead, compiling for fast testing is focused on enabling the program to be automatically tested with randomized or mutated inputs. Debugging is about finding and fixing bugs by allowing you to step through the code and track down the root cause. Fuzzing is about automatically generating inputs to discover unexpected behaviors, security vulnerabilities, and edge cases that may lead to crashes or bugs. Okay. Okay, then sanitizers. To compile with sanitizers, build with Clang using the following. Compiling with msan is quite involved. For running tests with msan, it's probably easiest to just compile normally and then invoke valgrind. Okay. Alternatively, you can use the CI system to run a sanitizer task. See the sanitizer section of the Bitcoin Core Developer Note for more information. If you're seeing any odd issues while compiling, trying to use make clean, if that doesn't work, blah blah blah, mcache-c, run the unit tests. So I was here. Pro tips: for now I will just leave them like this, and I will just run the unit tests. I mean, it's still running the compilation command. Okay. Then the functional tests. I will just leave the system to finish the execution of this command. Okay, therefore I wasn't expecting such a long time for this operation to finish. Therefore, as it's taking already it's nearly an hour just for this, I will just close the streaming, and whenever it finishes I will just start another video to continue this one. In the next video, the steps will be to run the unit tests and the functional tests. Therefore, I hope to see you in the next video. Thank you very much. I appreciate you being here, and see you next time.